Guys, so welcome back. Last time we were plugging in our basic GraphQL and had it working from inside Unity, at least at a test level. So we want to keep going with that. If you remember last time we just had our placeholder data here, and that's not going to be that cool because we want to use real data from a database. And there's a lot of options for us. Most of the time people use graph databases for these kind of JSON document type of data, but you can use any database that you want. I think today what we're going to do is to use SQL. SQL is nice because it runs everywhere. If we know the schema, actually, it can be very performant, and it's implemented on almost every platform. So we can run it natively on a phone. We can easily run it on a local machine. We can run it in the cloud. There's cloud versions of it, functional interfaces to it, and so on. So just easy to do. So why don't we go ahead and get started by making a database, and then we'll try to connect it up. So the first thing to do, of course, is to fire up the old SQL Explorer. See if we got that on the old machine here. Yes, here we go. And we even have it installed already. Of course, we have to remember what the password is. Let's see how that works. All right. And we have a couple databases here from other projects. That's all good. Let's go ahead and create a new one. So if you remember, in SQL, whenever we are trying to make a new database, it's basically really making a new schema. So let's go ahead and call this what the flock data. And hopefully there's no special settings we need here. I often get this wrong, but let's go ahead and create it. Lock type default looks good to me. Let's make it. And there we go. So far we have no tables. That's fine. We can do all that later. All right, so we'll keep this around. We don't really need to do anything special on that one right now. Just close out these other windows here to get a clean slate. And I think we are good. Okay, now what we want to do is connect to this from our node instance. And again, there's many different programs people use for this. I like one called Sequelize. So let's take a look at the old Sequelize documentation. So it tells us how to install it and some documentation on it. Let's first do the installation. We're just going to paste this right in the terminal window here inside IntelliJ. Well, that didn't copy well. Shall we try that again? Well, okay. I guess it does not feel like copying. That's okay. Pretty sure it's just Sequelize anyway. So that's thinking about it. We'll let that go for a bit. Well, that's working. Let's go ahead and make a folder for our SQL stuff, or a file. Basically, there's two steps that we're going to have to take here. First, we're going to have to make a schema for our database in Sequelize. And once that's done, we're going to have to set that database as a data source for Apollo GraphQL. So we'll do both those steps today. And while it's installing, let's take a look from our other project on what that looks like. Well, it looks like we're not going to get any performance here until this is done. So that's good. It looks like it has finished. Cool. All right, let's go back and see what we're going to be doing here. So first thing we have to do is we have to define our SQL database file. And basically, we are going to bring in Sequelize. We're going to create a new database object using whatever connection options we need. And then for each of our tables in the database, we're going to define what that table looks like in terms of the column names and the column types. And we can define enums in this way. We can define related tables and so on. Sequelize actually provides quite a few helpers, especially when you're doing associated structures, like when a table has complex parts and things like that. I tend not to use a lot of those. I prefer to just do it as vanilla as possible, but if you do like those and they work well for you, you can still use them. In any case, what this script does is when you run it, it will create all these tables if they don't exist. And if I look in our index.js, you can see that we pull this in, this create SQL here, and when we do this, it creates that store. And the first thing I do once I have that store is I tell it to sync, which basically makes sure that all the tables that aren't created are created, any changes are put in, and so on. It has a single parameter here called force. And what force does is if you say force, it'll drop all the tables and recreate them. So this is good when you're doing a lot of prototyping and changing schemas around to do. The next thing that you'll see that we do here, when we create our server, before we were just passing a type def and a resolver. We can also pass in data sources, and we can also pass in a context. Well, you get to context later. That's where we put in things like, it's basically the node context here for the server. So we put in things like the authorization tokens, user IDs, other kind of cache data, anything you need for session management, basically. But data source, you'll see, is a useful one. Data source is going to be a function that returns all of the data sources in the app. So with that in mind, we can actually copy some of this stuff over, but let's first start by making our database. So let's go to the SQL-based file here. I'll just copy a few things. Again, as a novice developer, I always prefer to take code that I know works and copy it and modify it. That's kind of how 99% of my programming is done. Once you get something working, don't mess with it. And then gradually decide what you're going to do over and do better the next time. So let's start. We're going to make a new JavaScript file here. And I'm just going to call it the SQL database. And of course, we want to add it to source control. And what I did here is I just pasted in the exact code from the old one. And you can see there's a bunch of stuff here that we're not using. We don't really care about all the stuff we put in here to make it work with App Engine, which is kind of what I use for that other database. And give it localhost and password. Obviously we'll change that, but for the purpose of video, why not, right? And then when we do the Sequelize command, we have to give it the name of the file that we used in our SQL program, of course. So let's make sure that's looking good. And we called it W2F data. So we will do the same thing here. All these other options should be exactly the same, since that was what was working before. And then we can define our first object. And we don't have users right now in our system, but that's okay. We can go ahead and make a user object here just to show that this works. And one thing we do want to do here, if we switch back to the project, is usually at the end, we'd like to export these things. So we're going to be returning all these objects that we created. In this case, we're only doing these top two, so we don't quite need all of them. And that should do it. So again, we kind of got all those things in, copied over, and we're pretty good. So we'll have these two things exported for us. And now let's go look at our old index.js file here and see how we do this. First thing, of course, we'll have to bring in the database. Let's call it SQLDB. And if we remember those steps, we need to instantiate the database, and then we need to sync it, and then we need to pass it in as the data source. So let's start with these two. And then in our Apollo server here, we're getting a little bit more complicated. Let's start breaking these things up into their own lines so we can see what's going on. Just like before, this is the config. We have type def, resolvers, and now we need our store. Oh, we have to actually create this object too, let's not forget. Let's just grab this whole piece of code here, and we'll show you what this is all about. This is basically the thing that makes the SQL thing wraps it into the data source that we need for Apollo. Let's call this the API. Pass our store in there, and we'll get to that, of course. And then oops, wrong key. Okay, so now what is this object here, do you think? So what GraphQL does is it wants us to have the data store. So let's go and take a look at what that looks like here. What is a data store? Well, if I look at the resolver, what we'll see here is that the resolver is passed a collection of data sources, which is just a data source object that all these data sources are bound to. Then I can call methods on them from inside the resolver function. So what I did here in the last app is we defined data sources for every object. Might be overkill for a more simple thing, but that's basically how that one worked. And then we have this class here that basically is going to create these things for us. So let's take a look at what has to be in here. So data source is going to be defined with Apollo GraphQL. And it's going to have things to initialize, and this is what it's going to assume that we've already filled in. After that, you can put in whatever you want, and you just call methods on that data source. And a common way people do this, that I did here, is for every type of object, we could have another subfunction defined that has all the getters and setters for that object. For our current thing, that's pretty much overkill. We don't need anything quite this sophisticated just for storing a couple levels. So that's okay. We're going to do just take this top line here and create a new file that we're going to call the API. I really should check that box one of these years. Once I have the API, everything else is not really needed. I'm just going to call this function here. It's going to extend it. And we have the various creation methods that are going to get this data source created. So we'll just copy these, and then we'll remove their bodies, since we won't be needing them. Let's get rid of all this stuff. And you'll see that we have the store, we have whether it's initiated, and we should be good. So the store function here is going to be, because we create this out of the store, you'll see that we're just passing this in here. And we can go talk to this thing now. Fix up that one quick, and also let's be sure to include that other file. Okay, so we have to resolve that type as well. And again, whenever we have these things defined, we always have to go and be sure that we're bringing them in. So here, this API is actually generated from here. Okay. Have the API defined. Now let's build out this function. And we're done with this class. And now we have to do our export. So if we're going to actually find this thing, you'll see at the end, we always have to export the function from the module so that we can actually find it. Oops, API. Okay, so now if we try to run this, even though it doesn't do anything cool, it should still work. So let's give it a try. And again, this is one of these things that as a less experienced programmer, I do a lot, just because I like to know stuff works. Try to keep working code at all times. And we can see we have a little problem. WTF API is not defined. On line 9. Well, that looks like it should have worked. Oh. A little typo there. That is the downside of doing a lot of copy and pasting. You make a lot of copy-paste errors. Oh, we got slightly farther this time. Down to line 11. And now it looks like our SQL database call that should just probably be the DB, right? It looks like our export was not formatted quite right. I'm just going to make this a little bit smaller here so we can look at them side by side. So you'll see here in our SQL DB, we actually do not want to bring in everything. We really just need this create SQL function. And then in our index, we can just call that function. And now we can do our sync. And now it looks like we forgot something here. Oh, the username function. Probably something we deleted when we did our copy paste. All right, let's see how we're looking now. All right, through error. Please install modular name. We did not install the MySQL 2 package. Well, interesting. Let's just see if that's actually what it's called. GraphQL subscriptions requires a pure. Well, Don't know what that's about, but I assume we'll get to that later. Server ready. Great. Well, now here's what should happen. If we look at our SQL table now, we should not have any tables defined, if you recall. So let's refresh. And now we have our users table. Well, that's very exciting. And look at that. It has all of those things that we had created. Cool. So that just means that it's working. So now let's go through and add the objects to SQL that we actually need, because we actually don't need users. But what we do need are all of the objects that we had in our C# file. And we can just go ahead and do these one after the other. So we have our sheep object. And the way this works is the first word is the table name, and then it's an object of all of the properties and their type. So that's a very simple object, and we're going to have a lot of these simple objects. We have the sheep, we have the single object, we have the fence, puddle, dog run, a hole, star, rabbit hole, and of course the level itself. So let's go blow these out. Single object, we add the angle, fence, puddle, whoops, one puddle here, we just have to add the width, height, and angle. We'll try not to make the same errors we made last time of keeping switching X and Y instead of X and Z. Okay, so now we're going to start getting into the interesting things. We can't actually embed types of objects in SQL. Every column has to be just one of the primitive types. So what we can do instead is we can make a reference to another object here. So I could say this is actually going to be an integer, and I can have that be a reference to the other object. And to do that, and to make it clear, we might even call this the ID of that. So, and you may be wondering, what is this ID? Well, let's flip back to SQL here. And what you'll see is that even though we didn't define it, when Sequelize made this, it added a few extra fields to it. And it does this to every object unless you tell it not to. It'll add an ID to it. And I'll also add a date time of when the object was created and a date time of when the object was last updated. So again, we don't have to declare these fields. They're added to every object, but we can refer to them. And we're going to use the ID field to make references to other objects. All right, so rabbit hole, we're going to have an ID for the entry hole and an ID for the exit hole. And finally, we have the level itself. And just like we did in our resolvers, let's take a look at this here. For our level, we really only included the primitive values. And everything else, we wrote a special resolver function to resolve it. And there tends to be a one-to-one mapping between how you do this in the resolvers and when you're going to use a separate table in SQL. So kind of an interesting thing there. So let's go through and see what we actually have in our level. So we don't need the ID because that comes with the object, but we're going to need the width, which is an integer. Oh, sorry, it's a float. We're going to need the exit, but that's an object, so we're going to do the ID. We're going to need the name. The description. We're going to need the allowed time for sure. And what else? Fence objects. These are going to be lists. We have bushes. These are all lists. List. The sheep is going to be a list. Dog on stars. Everything else is going to be a list. So for those, we can't use members of here. What we do is we make association tables. Now, as I mentioned, this is something that Sequelize will do for you using their syntax. You can actually declare members in a one-to-many, many-to-one, or many-to-many way. But just so we can see what's going on, we can also do this ourselves. So just to show you guys how to do this in SQL, right? So I can make a table that's called something like, let's start with sheep. I can call it sheep to level association. And I can define this as this is going to be a many-to-one association. So I can say I'm going to need the level, which will use an integer, and I'm going to need the sheep. And again, the level will be the level object, the sheep will be an item in our sheep table. And we can actually qualify that here. We can actually set up that associated table, but let's not get ahead of ourselves. So what else do we need to associate with a level? If we wanted to, we could make a separate table for every one of these objects. Now, there's other ways of doing this. We don't really have to make separate tables for all of them, but in the interest of being really clear, we can. So we need sheep, fences, electric fences, bushes, puddles, mud puddles, holes, dogs, stars. And for each of these, we're going to make its own association table. So let's go ahead and do that. We have a fence to level. We have electric fence to level. Bushes. Puddles. Mud puddles. What's left? Holes. Dogs. And finally, stars. All right, so these association tables then, we can query them and find the related objects. So something that we will be doing at some point. In the meantime, let's stop our server here because it looks like we left it running. And again, going back to our MySQL, right now we don't have much of interest here. Do a quick refresh, and again all we have is our user table. Let's run it again. Make sure we don't have any errors. Our server's ready. It's not too exciting. We actually aren't changing anything to use that. But if we look at our database, now we will have all of those beautiful tables in there. All right, well, that's part one of this. The next thing we're going to do is we're going to start talking to these guys here and using this. And just to give you a quick preview, we'll do this in another session, but to give you a quick preview, remember when we had called these functions here, we just left these things blank. And so, but what exactly are these parameters that we're passing in? Well, if we go and look at our other project, you can see that zoom up here to the top, that when we do these queries, like levels, the third parameter is the data sources. So now we can actually pass in that data source. And in our data source, we'll be able now to reference our SQL data source that we made here from our W2F API. So if I define a function here, like let's just make a function here that says get levels, which we'll just say doesn't need anything. And we could just return this exact same thing. Now we can actually call this function here from the data source. So instead of calling it here, we could call it and our data source, if you remember, is the W2F API. And again, now, if we run that, we shouldn't see any change. It should still work just fine. And if we go check this out, you'll see that it still works, still does the same thing, except now it's going to be calling our function inside getLevels. And what we can do is we can actually change this function to return stuff from our database. So to do this, we have to make a query of the database. So we have the database store here, so it's really just a matter of issuing that query. Let's take a look at what that syntax looks like. If we go back here to our data source and look at one of these objects, say a planet, or the model base, I think might be better. You can say that we have this very nice function, getAll, that for any table will find all of the objects and return them if needed. So let's go ahead and we can do this same type of thing here. So how we really want to get the levels is to say go to our store, and our store we have levels, and we can do getAll. So if I look at our SQL database here, but we do have to export these, which we actually never did. And we can also get rid of this user one here because we're not using that now. So to make sure we don't miss anything, let's split the window, go to the bottom, and see what we need. We need the sheep object. And you'll notice that as I enter in this export here, this gray, which is indicating unused constant, becomes green. This is a nice way of checking to make sure you haven't missed anything. All right. And then, of course, our association tables. We may or may not have to use these because we probably will never reference these fields directly, but good to have. All right, I think we got everything. Looking good. So now we can reference our store. And that should work. Looking nice. Put a necessary semicolon. Cool. Let's take this off. So now, when we get this, it should fetch the levels from the database. So let's take a look and make sure that's working. So if you've been playing along, hopefully you have a good sense of what will happen here. What's going to happen when we try to fetch these levels from the database? Well, that's not what's supposed to happen. Definitely was not supposed to be do nothing. So let's see what we messed up. We messed up because we have a capitalization error. That was actually not what I was going to show you. Oh, level should work. All right. Now we have to start figuring out what's going on. Okay, let's set a breakpoint here. And we'll go here and try to query this and see what our problem is. Oh, we have our level object. Our level object is defined. So let's just add our time to do some debugging. So let's attach here to this node instance. And now we'll run it in our debugger. Server's ready. Let's take a look. And now we can see what's up. Well, it has level. Let's do some introspection, shall we? Well, this looks like the table here, so I'm going to guess that we need to change our syntax here a bit. I'm going to stop this one. And let's look back to what we're doing here. Find all. Well, there we go. That will help. Let's run our debugger again, shall we? Perfect. Now what we'll see here is it's doing the expected thing, which is to return an empty list. So now let's just make sure that it's working by adding some data into our SQL. Let's go to our levels table. And we can edit in an edit grid. How's that? I'm going to leave the exit ID blank for a minute. Test level. This is only a test. 15 seconds. Next level, 15 by 15. Call another test. This is another test. We'll give this one 40 seconds. And we're going to apply. And we have an error. Oop, created at. Well, it looks like we actually have to fill those in. What is it today? I don't know if this is going to be the right format for a date here, but we'll see what it does with it. Incorrect date time value. Well, you know, let's just look at our user table and see what a good date time value looks like, shall we? Well, now we guess that you're going to have to take a look and see. All right. Date time. Year-month-date. Let's try it. that seemed to have worked. And if we go here and query this field, we should now be able to retrieve it. Oh, that's users. Ha! There we go. We have levels, and if we go to our GraphQL, we have levels as well. Now, you're going to see a very interesting thing here. You'll notice that even though we haven't defined any sheep or exits or dogs or anything like that, they're here in this file. Why is that? Well, let's keep in mind that when we define the resolvers for this, we actually just hardwired those in. So in our next session, we're going to plug in the rest of those fields and show how we fetch those from the database as well. In the meantime, I think we got to a good point tonight. We got some good code working. We don't want to overdo it. Let's clean up some of these comments here, save everything, and we're going to call it a night. Thanks for watching.